Hello everyone, welcome back. We are going to another problem here. So frog removal one. So this is also a codility problem. So this is also an easy one. Find the earliest time when a frog can jump to the other side of the river. So a small frog wants to get to the other side of a river. The frog is initially located on the bank of the river, position 0, and want to get the opposite bank. Position is +1. Leaves fall from a tree onto the surface of the river. You are given an array A consists of n integers representing the falling leaves. K represents the position where one leaf falls at 10k. So if that means A of k means A of 6, A of 5, A of 4. So in this case, if I am giving an array of these things, you need to find when they can reach the fifth position. So for example, you are given an integer 5 and array is that in second 6 a leaf fall into position 5. So this is the earliest time when leaves appears in every position. Okay, so we can go to the solution here. So if you are not that much understand, probably you will understand when we are going through the problem solution. Okay, so here we define a set initially, and since I need to reach the x position, so I am taking it as a y is equal to 0 and initialize all the way to add all the way to um, add all the way to x. So I'm saying like, so y is equal to 0, or I am going to add 1. Y is equal to 1, I am going to add 2. Y is equal to 2, I am going to add 3. All the way to, since it is less than 5, it will add up to 5. So we are fine. So for this example, so we assume x is equal to 5. Okay. So what exactly happening here? So if I am providing this much of items here, so 5, 4, 4 is the last one. So if I am saying like I am providing this whole item also here as an input, so we can expect all of this item is coming into picture. So I am checking says contain number 5. So here says contain number I. So says contain number I, initially it was 1. So says contain number I. So I am just removing that element. In the first iteration I am just removing the 1, and in the next iteration I am just removing, I am taking the second element 3, that also in this one. Oh, okay, what is happening here? So in the first iteration I am removing this one. Okay, the second iteration I am removing 3. Okay, 3, I am removing 3 from that. If 3 is there, 3 is, if return I. If set is empty, then only I will return. So right now set is not empty, so I am going to the next element. So I'm going to the next element, and all the way I will reach, okay, all the way I will remove all these elements, then I remove this one. So what is exactly happening here? So since this is my time array, so initially I will remove 1, That's fine. So 1, zeroth index. Then I remove 3, first index, and I am coming into, oh, I'm doing so many stupid things here. This is the array that I am getting here. This is the array that I need to remove. Okay. So in that case, what is happening here? So the first case, I am getting the first. That's fine. I'm removing first from here. The second case, I am getting 3. I'm removing 3 also from here. In the next things, I am getting 3. It's not in the sets, so I am not removing anything. I am just moving into the next index. 1, that also not there. I am going to the fourth one. That I am removing here. And I'm going to the second one. That also there. I am removing that one. And then next I am going to the third one. That also I'm not removing. I am, but it's not there. So that's, this is the last one. So I am removing that one, and since it is empty, I am returning the index of this one. So 1, 2, 3, 4, 5, 6. So I can see like my index is 6 because it will start with 0, 0, 1, 2, 3, 4, 5. This is the sixth index. Okay, so that's the one I am returning. So this also a little bit easy program. So I just setting the initial things initially, like 1, 2, 3, 4, 5. That's where I need to reach the other side of the river. 1, 2, 3, 4, 5. Then we will take each element. We will check all these elements. We need to have all these elements to be removed, and also we need to have the set should be empty. That's the only condition. So so everything is fine. I guess we found the solution. Thank you for watching. But before we are going, we can run this one, and we can see that the answer is 6. Thank you for watching. Have a nice day.